This is a quadratic equation in standard form, y equals x squared plus 6x plus 8. And this is the turning point form of the same equation. You can get the y-intercept from either form, but the turning point is easier to get from the second one because the numbers are in plain view. So how do we get the turning point form? By completing the square. This technique has something to do with area and can be used on any standard form like these other two examples. Getting the turning points are really easy from there on, so let's see how this works. G'day guys, this is the Math Base. Completing the square is about area. So let's say we have a square with a side length of x units and 6 rectangles beside it with matching height. Let's say each rectangle is 1 unit wide. The total area would be the square plus the rectangles, right? So our total area is x squared plus 6x. Now this is where things get interesting. We're going to rearrange this shape so that it takes up less space, but we have to be efficient about it, so we're only allowed to move the rectangles once. Here are 3 ways we could do that. Which approach do you think saves the most space? The answer is the L shape. It's not too long, nor too wide. Its rectangular outline is actually a square with a side length of x plus 3. Taking note there is a void in the bottom right corner, which is 3 by 3 units in area. Subtract this void from the largest square, and we have x plus 3 squared minus 3 squared. This is still the same area as before, but we used a different approach to get it. So we can conclude x squared plus 6x equals x plus 3 squared minus 3 squared. And that is how we complete the square visually and mathematically. The last step simplifies it to the turning point form, x plus 3 squared minus 9. If we added 8 to the original equation, that would be an extra bit of area that is attached to the original design. This area simply carries over and is not involved in the operation. All it does is change the number outside the bracket. This is how the first example was done. So completing the square does not involve the constant. The constant only plays a part in simplifying the area calculation to the turning point form. From the standard form, we can see the y-intercept is positive 8, giving us the coordinates 0, 8. From the turning point form, we take the opposite sign of the number inside the bracket and pair it up with the number outside, giving us the turning point of -3, -1. So completing the square is basically about using half the rectangles or the b value from the standard form. But what happens if b was negative? Let's check out the second example. Y equals x squared minus 4x plus 5. If I were you, the first thing I would do is write this setup so that it's easier to fill in the blanks later. Now, the b value here is -4. It's like saying there are 4 negative rectangles. Huh? Well, at the end of the day, maths is still maths, even if these rectangles only exist in the nether realm of Minecraft. So all you need to do is divide -4 by half, giving us -2. This goes into the first bracket. Copy the 2 over to the second bracket, and we're done. From here on, just simplify, keeping in mind the first bracket stays. Once you have your turning point form, you can obtain the coordinates and even sketch a graph for it. It's worth noting that this example does not have x-intercepts, because the turning point form was adding the constant outside, rather than subtracting it. So you can complete the square for anything, but not everything can be solved or factorized. Alright, on to our third and final example. This last one deals with fractions. The reason is because the b value of x squared plus x minus 12 is +1, which is not divisible by 2, so we're left with a fraction, preferably as an improper fraction. So +1 gives us +half. And here's a little tip. When you've expanded the second bracket and are about to minus 12, don't bother writing 12 again, just multiply it by 4 on 4 to match denominators with what you just expanded. This way, you can immediately evaluate it for the final step of the turning point form. And since we subtracted the 49 on 4, we can see the graph has x-intercepts, which are worth solving for at some point. But that's a problem for another day. The last thing I'll say about completing the square is that it can be quite challenging to do if the quadratic equation you're given has a leading coefficient of anything but positive 1. Personally, I would avoid it and use another method like the axis of symmetry, but it really comes down to what you're most comfortable with. Each method has its own merits and imperfections. But that is all the time I have for this video, so if you guys enjoyed it and found it helpful, please leave a like and let me know what you guys think in the comments below. Also subscribe and ring the bell to stay tuned for the next one. Thanks guys, see you next time.